Hi, in this tutorial we are going to solve a question related to diels-alder reactions. The question asks, predict the product of the following diels-alder reaction. Let's look at the reactants. We have here a diene. It has two double bonds, two alkene functionality. It's a conjugated diene. And if you look at here, the other reactant, it's an alkene, or it's a dienophile, and it has two electron withdrawing group, two ester functionality around double bond. So we can predict the product for the reaction. But let's check first of all the conjugated diene. If you look at carefully here, the conformation of the diene is actually S trans. We learned that for diels-alder reactions, the diene has to assume S cis configuration. So since this bond, sigma bond, can rotate, it can assume a different conformation. Let's write here. So instead of this conformation, we are going to rotate this bond. So let's draw here okay. Instead of facing up, it will face this way. So this is as a cis configuration. Then we can basically react this diene with this dienophile. So let's move this one over here. We will have more space. Then we can continue for the reaction. Then let's write again the dienophile in proper orientation so that we can predict the reaction. So I'm going to redraw this dienophile. So I'm going to place the alkene functionality double bond here so that we can predict the reaction product. So let's draw ester functionality here. Then I'm going to use a different color to predict the new bond formation between diene and dienophile. As you know, it's always easier to number the diene and dienophile so that we can track the new formed bonds. So let's start from diene. Let's number from this end 1, 2, 3, and 4. So we have here 4 carbon, and in the dienophile, let's continue numbering the alkene functionality with 5 and 6. We don't have to number the other atoms because the bond formation, new bond formations will occur in these 6 carbon atoms. So let's use a different color now, the bonds that will form. So we know that when diels-alder reaction happens, there will be 2 new sigma bonds forming between diene and dienophile. So the end of diene is going to make a bond between with the alkene carbons, and this end also will make a new sigma bond with this carbon. Then here we will form a new pi bonds. I'm going to again specify it with dashes. So that is going to be our new product. Let's move it here. We have more space there. So let's again draw the molecule. So let's write these new sigma bonds. So it's going to be this one, and this one. And let's number again so that we will not lose the track. So this one, number 1, number 2, number 3, number 4, 5 and 6. As you see, 5 and 6 should have 2 ester methyl ester functionality. Let's draw it. Okay, then let's not forget this new pi bond between 2 and 3. Let's draw it here. Okay, so in this question we we have seen that the Diene should assume instead of S trans configuration, it has to assume S cis configuration. Then diels-alder reaction can happen, because in this conformation the orbitals cannot overlap to make new sigma and pi bonds. So that's the reason why the molecule, the diene, has to assume S cis configuration. Thank you so much for watching this video.